guys, in this video I'm going to talk about something called outliers and skew. So the first thing I'm going to talk about is skew, which when you hear about this is when we're actually talking about the shape of a distribution. So basically when I put all my data on some sort of display, so these are histograms. We're going to look at something called box plots later on. You could also see this in a dot plot, things like that. But basically, we're going to kind of use the histogram to help us out here. So if you kind of imagine, right, this like peak, if I have this long tail to the left, we're getting what we call a negative skew, or we can also call it skewed left. This happens when the mean is less than, and I'm going to write that beneath, less than the median. If the mean and median are really close or exactly equal, we say that there's no skew, or this can also be called symmetric, okay? And then skewed right is the opposite of skewed left. We have the peak on the left and the tail to the right. And that happens when the mean is greater than the median. And again, I'm going to write greater than here so you know what that symbol is. Greater than the median. Okay, so these are just some more pictures with descriptions, you guys. So a normal distribution, I'm going to add here, you guys, this is when we were describing the shape. Okay, so if we're asked to describe the shape of the data set or of a distribution, this is what they're talking about, is talking about skew. So if there's no skew, it is what we call a normal distribution. The mean, median, and mode are all right around the center, okay? And the mean is at the peak of our data. Now, a negative skew or skewed left, right, is when the long tail's to the left, the mean is less than the median. So the peak is, or the mean's to the left of the peak is what happens there, okay? And again, positive skew, we can also say that is skewed right, okay? And so my tail is to the right and the mean is to the right of the peak, okay? And so that's what we mean by talking about the shape, is it skewed which way, or is there no skew? Okay, so why is this important? Well, we can be asked to talk about centers, right? Remember, mean, median, mode are measures of central tendency, are measures of center. So we can describe data using any of them, but which one is maybe better given a situation? So if I'm asking which one would be better to use, the mean or the median, to give this center of data, the age of men and women at their first marriage. Okay, so I'll just give an example. I got married super young, 21 is when I got married. And my cousin got married for the first time at 42. So our ages are pretty spread out, okay? So the average just between the two of us would be 30 something. Now, I don't necessarily know that that's the best way to describe that data, okay? So the median is like, well, what's the middle? What's like exactly the middle of all these different ages of married people and when they got married at their first marriage? So the median in this case would be actually a better measure of center, or a better average. And the reason is because there could be, we kind of call these outliers. And I'm going to talk actually more about that in a second. So there could be some people that get married way older or way younger that totally skew the data. If you were to think about a typical age people get married, you would probably say in the 20s. Honestly, that probably would be the average, is somewhere in the 20s. So when you hear someone getting married for the first time, 40 or 50 or 60 or whatever, those are going to skew the average. So when it is skewed, the median is a better measure of center, okay? So median is better. I'm just going to add this here. Median is better when data is skewed. Okay, now let's talk about test scores. So what would be better in describing that? Well, when you guys think about a student, at least what I see as a teacher, is most of the time students score similarly on all their assessments. Now, obviously that doesn't happen all the time, but typically if you've been getting B's on quizzes, you're probably getting a B on the next quiz because of your study habits, your amount of practice, your previous knowledge, how much help you got, all of those things. You're usually practicing those same things every unit. If you're a D student, you don't do your homework, you miss a lot of class, etc., that's going to continue throughout all of the units. So your quiz scores or test scores are probably reflective of that, and they're probably pretty consistent. So this one, the average is probably pretty close. Now, it's not very typical that you see someone who's gotten B's on most of their tests and then all of a sudden get a 13%, right? It doesn't happen super often. So this one, typically, the mean would be better, okay? Most students score similarly on assessments. Okay, so there's more consistency. So there's not typically outliers, okay? So the mean is better if there's not going to be skew, okay? So mean is better. Sorry, that's a funky looking mean. For no skew. All right. All right, 5 number summary. We have already done this. Minimum, maximum, first quartile, third quartile, and the median. So remember, Q1 is the middle or the median of the lower half of the data, and third quartile is the median or the middle of the upper half of the data, okay? And then remember, we can find the IQR or the interquartile range by doing Q1 minus Q3. So all that's review. We've done that before. This piece is new. Okay, so I kind of threw out that word outlier. We're going to talk more specifically about how do I decide if something's actually an outlier, because we kind of have an idea of what that is. Like it's way far apart from the rest of my data, but like where do I decide? What if it's on the bubble? We actually have a mathematical way to calculate whether a number is an outlier or not. And we have what we're going to call fences. So if numbers are outside these fences, they're outliers. Okay, so numbers outside either fence are considered outliers. So that's kind of what's happening here, you guys. Any point that's greater than the upper fence or less than the lower fence. Okay, so on either side, they're considered outliers. Now, what if they're exactly equal to the fence? That's okay. They are not considered outliers. All right, let's do some examples. Okay, we're going to do this first one by hand, and then the second one I'm going to use Desmos, you guys. Okay, so here's what I am going to do. And actually, I'm going to do example 2. So this is, if you're given the option, you guys, the ones that have smaller data sets, that's a little easier to find by hand, right? The bigger the data set, technology is a great tool. All right, so I'm going to do this one by hand just to remind you. So we're asked to find the 5 number summary and the mean, decide which numbers are outliers if we have any, and then defend your answers mathematically, meaning basically show your work for how you decided if something is an outlier or not. Okay, these are already in order, which is great. So let's go ahead and find, so let's see, we got 1, 2, so example 2, that 2 is not part of my numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 1, 2, 3, 4, 5, this is the middle. Because it's an even number, we're actually going to take the average of those or the mean of those. So the middle of 7 and 8 is 7.5. So my median is 7.5. Okay? All right, so the middle of the lower half of the data. So if the median is actually right here, right? The median is 7.5. So Q1 is the middle of the lower half. So here's 1, 2, 3, 4, 5. So that would be the middle of the lower half. So that is Q1. 1, 2, 3, 4, 5. So again, the middle of the upper half, that's Q3. All right, so our minimum, I'm going to write this just a little nicer. Minimum is 2. Q1 is 6. Median is 7.5. Q3 is 9. Max is 18. All right, the other thing I'm asked to find is the mean. Okay, so mean is add them all up and divide by how many there are. So remember, our symbol for mean is x bar. So I'm going to do x bar equals, add them all up. So we got 2 plus 3 plus 6 plus 6 plus 7 plus 8 plus 8 plus 9 plus 12 plus 18. There were 10 numbers there, so then I'm going to divide that by 10 to get x bar. I'm going to use calculator to assist me here. All right, get where you guys can kind of see it too. There we go. All right, so we got 2 plus 3, 6. All right, so we got 74 divided by 10 gives us 7.4 for the mean. Okay, the last part we're asked to determine is outliers. So here's what we're going to do. So we need to find the fences, okay? So remember, the lower fence is equal to our Q1 minus 1.5 times the IQR. This is on the previous page, okay? So we need to find the IQR. So IQR, remember, is Q3 minus Q1. So for us, Q3 minus Q1 is 3. All right, so now our lower fence, if I plug numbers in here, so Q1 is 6 minus 1.5 times 3. And actually, I'm going to type it in like this, you guys, so that you can do it on your calculator all at once. So we're doing 1.5, 6 minus 1.5 times 3. So we got 1.5. Okay, so I'm looking at my data set. Do I have any numbers less than 1.5? We do not. So we don't have any outliers on the low end. 2 is my lowest number. It's not lower than the lower fence, so we have no outliers there. So let's check the upper fence. Okay, so the upper fence is quartile 3 plus 1.5 of the IQR. So again, plugging in the numbers we have already for that. Q3 is 9 plus 1.5 times, again, the IQR is 3. So we're going to do 9 plus 1.5 times 3 to get our upper fence. So 13.5. So now I'm looking for, do I have any numbers bigger than 13.5? I do, 18. So 18 is an outlier because it is greater than the upper fence. So lower than the lower fence or greater than the upper fence are outliers. Okay, so we did everything we were asked. We found our 5-number summary, the mean. We determined where they're outliers. This would be the math to defend our answer. Okay? All right, so we're going to do number 1. We're going to do the same exact thing, you guys, but I'm going to use Desmos to help me out. All right, so remember when I use Desmos, I need L equals, and then I'm just going to enter my list. So we've got 5, 6, 7, 8, 9, 9, 10, 11, 15, 18, 19, 20, 24. Okay, so now we were asked to find the 5-number summary as a reminder where that is. So find that keyboard. If it's not showing, pop it up. Go to Functions. Under Statistics, we're just going to hit this Stats button and then type L. There's my 5-number summary. So I'm going to write those down on my page. So our minimum is 5. Q1 is 7.5. Median is 10. Q3 is 18.5. Max is 24. The other thing we're asked to find is the mean. So I can actually just type in mean, I believe, and then hit L. Or I can go to Functions, Stats, and then choose mean right there. Either one, okay? So it's about 12.38 for X bar. Okay, so I just wrote all those down on my page here. All right, so we found everything using Desmos. Now, decide whether there are any outliers. So this site is always going to require a little bit of work by hand. So IQR, we always need that to determine outliers. So Q3 minus Q1, so 18.5 minus 7.5 is 11. Okay, so then I'm going to find my fences, right? So lower fence, okay, is our Q1, 7.5, minus 11. I'm going to always do the same order. Sorry, you guys. Minus, it's always 1.5 times the IQR. So 11. Okay. Upper fence is Q3 plus 1.5 times 11. Okay, so let's do some calculations there. So I've got 7. Sorry, trying to put that where it's not glary. You can see it. Okay, so we got 7.5 minus 0.5 times 11. So our lower fence is -9. Our upper fence, 18.5 plus 1.5 times 11 is 35. Okay, so I'm looking, do I have any numbers less than 9? Sorry, that's hard to see, you guys. There we go. Do I have any numbers less than -9 or bigger than 35? That means they're on either side of the fences. So in this one, I do not. There's no number less than -9, and there's no number greater than 35. So no outliers, because none of the values are beyond the upper and lower fences. All right. Okay, that is it, you guys, for outliers and skew. Oh, I was going to add one more thing to skew. Maybe I'm not yet. Okay, sorry. Not just yet. All right. Thanks for watching.